In this video, I'm going to talk about modeling strategies for division of decimals. There's a few different ways they throw pictures at you. One way that you're going to see is when they give you a problem, sometimes it's going to be represented with base 10 blocks. So 3 ones would be 3 squares, and 21 hundredths is going to be 2 tenths and 1 tiny block, or I like to use dots. So if I'm dividing this into 3 groups, it's easy to go ahead and split these 3 ones and put 1 in each group. This gets a little trickier. So 21 hundredths can be 2 tenths and 1 hundredths, or I can break these up into 10 pieces and 10 pieces, so I have 21 dots. So from here, it's like dealing out cards. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Now, this is not the fastest way, obviously, to do it, but I know 21 divided by 3 is 7, so it makes sense that I have 1 and 7 hundredths in each of these. So this is just one way that they split it up. They show you pictures and they ask you which equation will match it. If you add them all up, that's what you started with. It's divided into 3 equal groups. And then of course, my answer is going to be what is in one group. So the answer to this problem would be 1 and 7 hundredths. So this is just one way you're going to see pictures thrown at you. I'm going to show you one more. So this is 1 6/10 divided by 4. Well, here I can't split this one and this one into 4 groups. So I already know by looking at this, I'm going to have to make this into 10 tenths. So when you're looking at these numbers, if it doesn't make sense to split up the wholes because you've got to have 4 groups, then I'm just going to pretend this decimal isn't here, and I'm going to see it as 16 tenths. So if I break this 1 into 10, I have 16. And then it's like playing cards. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So when you're dealing cards, you want everybody to get the same amount of cards. So it's fair. When you're dividing into 4 groups, I'm just going to split them up like I would a deck of cards, and every person gets 4 tenths. So the answer would be 4 tenths on this one. The other way they model these problems is this way with these hundredths grids. So I'm going to show you a couple of other ways you're going to see it. Sometimes you're going to have shaded hundredths grids, and the groups are going to be circled on the hundredths grid. So I'm shading 8 tenths to start with on here. So if I wanted to show 8 tenths divided by 2, I'm going to split these tenths up into 2 sections. I know 8 divided by 2 is 4, so I'm going to circle 4/10 and 4/10. You're just basically outlining the different groups. Sometimes it'll be this way. I'm going to shade in 6/10 this way. And let's say I wanted to show 6/10 divided by 3. I'm just going to circle 3 groups of 2/10. So your answer is going to be what is in one group. So my answer to this problem is 2/10 because after I divide it into 3, I have 2/10 in each one. The answer to this, of course, is 4/10 because when I split it into 2 groups, I have 4/10 in each group. Sometimes you're going to have some wonky looking ones where you're not going to have tenths as the answer. You're going to have smaller groups representing hundredths. So this, for example, let me shade in. This is 32 hundredths. And let's say I want to divide 32 hundredths by 4. I know 32 divided by 4 is 8, so I'm going to circle groups of 8. And this is where you have these wonky Tetris piece looking things. So 1, 2, 3, 4, 5, 6, 8. One, 2, 3, 4, 5, 6, 7, 8. And then this last group is 8 as well. These I don't see as often because they're confusing models anyway to look at. But if you see that they've got a shaded area and they break it out into chunks, this is a modeling of division problem, and this is just the way it looks. I'm going to show